Anyway, so today we are continuing with our water labs. I have still more of our blue water, our special blue water that we've been using to learn about the water chemistry with, and I want to do another demonstration. And I don't know if you have microscope slides at home or two pieces of glass you could do this with, but you can do this at home. What I'm going to do, I'm going to take a microscope slide and I'm going to put a drop of water on it, and then we're going to do something else to it. Let me switch over to my Elmo. Everybody sees the slide there?
Yes.
Yes, thank
Yes.
you. Okay, so hold on. I'm going to put one drop of water. I'll make it 2 drops of water right there at the end. Everybody sees that? Yes? Now, what I'm going to do is I'm going to take this other microscope slide. I'm going to put it on top and watch what happens as soon as I touch the slide to it. Let me ask a question. Is water attracted to glass?
I want to say no.
I want to say yes.
Well, one of the things we talked about yesterday was that water is a polar substance, and there are a number of other polar substances, one of which is glass. Other ones include wood and paper and some metals, things like that. Non-polar substances are things that water doesn't interact with, and if you think about it, it makes sense that it would be things like oil and plastic and wax and stuff like that. Anyway, so here's what I have. I have 2 slides. One slide on top of the other. I push the top slide forward until it touches the water. You see what's happening there? Oh, cool, Mr. Auerbach. That's the most amazing thing I've ever seen. What is happening to the water? What is it doing?
It's. I'm not a man of many words, so I really don't know what to say here. Doing something.
How about one word?
It's spreading.
Water.
It's spreading. Yeah, I would say that's a pretty good way to do it. It moved, and actually it's done now. It moved all the way from one end of the slide to the other. It started there and it moved all the way down. Who wants to see that again?
I do.
Yeah.
Touching the water, and there it goes, racing across the side, and it's a water molecule ahead, and the other water molecule pulling ahead, and coming around the bend, it's the water molecules, and they're heading towards the end of the slide. And they're slowing down, but they're going to make it. I think they're going to make it. Look at them, those determined, plucky little water molecules. Now, the question is, why are they doing that?
I want to say capillary action, but that might be wrong.
Ooh, that wouldn't be wrong, actually. Capillary action. Way to pull out a very good term. For those of you that don't know what that means, capillary action is the way that substances move through very small spaces that are made of polar molecules. So let me rephrase that. Capillary action is what water does when it encounters a very narrow space made of a polar substance like glass or wood. As I said before, wood is a polar substance. And so this is actually how water moves up into trees. The water encounters the roots, which are made of a polar substance, and they just move up right along the inside of the vessels of the tree in this manner. And that is the magic of capillary action, which is sort of a combination of both adhesion and cohesion. It's adhesion because the water is attracted to the glass and it pulls itself up through there, but it's cohesion because also down at this end, you'll notice that the water is kind of disappearing as it pulls in. So the water molecules pull each other along because of their polar attraction to each other. So that's the first part of our demonstration, and I will ask you the question at the end to put on your study guide. Why did the water move through the space between the 2 slides? But now I want to show you a variation on that in which I have two different slides, but you might be able to tell these look slightly different because they're covered with wax. I took a candle and I rubbed it on the slides until they were more or less completely covered with wax. And so I'm going to put them in the same spot here. Here we go. I know you're all very excited. I will put a drop of water. Any predictions as to what is or maybe is not going to happen here?
I have a prediction that the water will stay where it is.
Stay where it is? Okay, let's give it a shot. So here we go. We have the other slide on there. Oop, I just slapped it right down on top. And so it did squish some into there, but I think we can see here that the water is staying put. It's just sitting there. It's not doing anything. And so that's the second part of this demonstration. And the question that goes along with this one will be, why does the water not move down the slides covered with wax? And I'm going to leave that to you to think about why that may be. If anybody has any questions, by the way, please feel free to put them into the chat and I will answer them. Brianna says, because the wax is not polar. Thank you, Brianna. That is absolutely correct. The wax is not polar. Unlike the glass, which is polar, the wax is not. And sometimes when you do this, you can see the water move up through little spaces in the glass where I was unable to get the wax to stick. But I want to do one more demonstration before we call it a day and head into our glorious weekend there. Okay, so I have here some aluminum foil.
Please tell me you're going to put it.
I'm going to put it on our surface here.
Oh.
Okay, let's see how that looks under our Elmo. It's totally rock and roll, man. All right, so we have that. And I am going to put down a nice puddle of our water here. Whoops. Let me zoom out a touch. There it is. There we go. Ooh, it looks like a shoe. There we go. Okay. So there's that. But I have another substance. Alcohol. So I'm going to take a little bit of this just plain isopropyl rubbing alcohol. And actually, hold on. I have another dropper for that. Do you see how it's kind of moving? When I put it right at the edge, you can kind of see it making some motion happen. One of the things that almost always happens here is that you can see the alcohol and the water sort of dissolving each other. There, you can kind of see it. You can see some sort of pulsating going on as the alcohol and the water interact with each other. It's not just two liquids sitting next to each other. They're actively sort of dissolving into each other. And let me share with another image that I want you to see. This is a crystal of salt being put into some water, and what you see is the action of dissolving, which is an active process where you have these water molecules here, and they interact with the salt crystals because they also have a charge. And this is what dissolving actually is the interaction of the water molecules with the different ions in the water. So here's the sodium and the chlorine that make up the compound. Let me show you a different picture because it gives you a more detailed view. These are the water molecules here, and you can see you got the negative oxygen and the two positive hydrogens, water being a polar molecule. And over here you have the negative and positive sodium and chlorine ions. And what you can see is that the way that dissolving happens is that water molecules will actually attract the ions. So this negative chloride ion over here is getting attracted to the positive side of the water molecules, as is also happening in a couple different places. And then you might also see, like, for example, this positive sodium ion is attracting the negative side of the water molecules, and eventually you end up with a situation where the molecules surround the ions in the water, and that actually is what dissolving is. This is also true with other polar things, like sugar is a polar molecule, and so water molecules will surround each sugar molecule, and that's what keeps it dissolved. And when you run out of water molecules to surround sugar molecules, that's when no more will dissolve. Alcohol is water soluble, and here's a couple. Here's a short list of some polar and non-polar substances. So you have this list: water, vinegar, blood, alcohol, sugars, hair, believe it or not, is polar substance. And all those things will tend to dissolve in water. And then you have non-polar substances like oils, waxes, gasoline, paint thinner, oil-based paints. Also, plastic is non-polar, and grease, stuff like that, which is why you can't wash grease off of your hands just with water. You have to use soap because soap dissolves non-polar substances. Anyway, that is our Zoom demonstration.